Hey, Aaron, thank you so much for taking the time to join us today on the show. I'm really looking forward to having a really interesting discussion with you around data ops for industrial IoT. So, welcome.
Thank you. Yeah, glad to be here. Exciting
Awesome.
times for sure. Yeah.
Great stuff. Yeah, so maybe for those for those in the audience who are not familiar with HighByte and yourself, maybe could you start off with an introduction about who you are and what HighByte is all about?
Yeah, sure. I'm CTO at HighByte. Been here almost 3 years, I think, going on. HighByte is really focused on data ops in manufacturing, which is kind of what we're going to talk about. So my experience in manufacturing, I started with Kepware back in '08, many years ago. So I think I'm going on 15 years in the space and just trying to stay up to with speed with what's going on that's new. But yeah, I worked for PTC, Kepware, and now HighByte.
Awesome, awesome. Yeah, so I mean, data ops. I mean, it's a term that is relatively new, especially to the OT world, right? So maybe to kind of like kick things off here, could you start by explaining to us what is data ops and why is it relevant for digital transformation in manufacturing?
Yeah, absolutely. So it is new in manufacturing, and honestly, it's fairly new in IT as well. I think last year I went down to we're based in Portland, Maine. I went down to Boston to a data ops conference in IT, and I went to a bunch of presentations, and it was really clear that like even in traditional IT, so e-commerce and stuff, data ops is still kind of fuzzy. Or not as mature as you would have thought. So like in manufacturing, it's usually a few years behind IT anyway. So it's very new to manufacturing. But the picture I would paint in terms of data ops, like the end goal is, say you're a large manufacturer, you have dozens of factories kind of spread across the world doing similar things, and you want to get that data central. Uh, so you can do things like machine learning, et cetera, on it. Like data ops, really the end goal is it's a team of people. Maybe it's a half dozen people in that organization, right? That has a backlog of from the business of things they're trying to do, mostly driven on use cases. So we're trying to do OEE is like kind of a traditional one, scrap reduction. We're trying to do energy monitoring, right? That team is responsible for taking those use cases and implementing the pipeline of data to enable them, right? And you can think of it almost like oil and gas. It's down in the factory collecting the data, it's moving that data, across networks efficiently, and then ultimately it's refining the data to make it available for applications in the business, right? And data ops is the people, the process, and the technology to do that at scale, which is the really important part because we can kind of, we've been doing it for a while, kind of cookie cutter building stuff that kind of one-off proof of concepts, but this is really like how do you do that across all those 50 factories with a team of half a dozen people.
So, I mean, for those organizations who are looking at going down the, I mean, we talked to a lot of companies that are kind of looking at maybe adopting something like the unified namespace, which we're going to talk about shortly. But at least as far as I'm concerned, really the starting point is to kind of look at how to put together that data ops layer, which really feeds the unified namespace. So for companies that are kind of looking at going down that path, what would you say are the key steps to follow when implementing a data ops strategy, or maybe a certain skill set that they need to have? What are the key elements to that?
Yeah, great question. So my first advice is don't boil the ocean, right? We see a lot of companies kind of get lost in digital transformation in general, trying to make it this really CapEx, you know, year-long, multi-year kind of initiative. And it's not that ultimately it's going to take that long potentially to get there, but it's actually not as difficult as some folks think. So the two mistakes I see people make the most is they start out with, hey, let's get all of our data into the cloud, right? And uh, that's a lot of work. You're solving some pretty tough engineering problems, and at the end of the day, the data might not be actionable anyway, right? So that's a tough place to start. The other place we see folks go is, hey, we're going to do a proof of concept and we're going to write our own code to do some manipulation, contextualization, movement of the data, right? So we work with a lot of customers that kind of start and try to roll their own, and then realize that they're not addressing the scale issue of data ops, because we got it to work in this one factory. Now we've got to go change the code. Now we're trying to maintain code. We make tractors or whatever. We don't write necessarily code. So they find themselves in that hole. The other piece is data ops, in my opinion, is use case driven. So like I said before, you're starting with OEE, or you're starting with energy monitoring, or some end goal that you want, and then you kind of work your way backwards to the data you need to try to prove out that use case. So I would think of it in terms of use cases, really similar to agile development, right? Like come into it, try to create a walking skeleton of how do we collect the minimal data we need, move that, contextualize that, get it into the application, and iterate quickly, right? My biggest advice when it comes to data ops and manufacturing is you're focused on, I call it the N+1 problem, right? Like we can build this pipeline, we can get the data, and as soon as we get the data in and we start looking at it and we learn, now we need something new. So we're going to have to go back down and like add additional data, manipulate the data, change the model, something. And what you're really focused on is, how do I reduce the cost of that change to near zero? So it's not like, can I get all the data to the cloud? It's not, can I perfectly model my data? It's okay, when I go to need to make a change at scale, how do I reduce the cost of doing that? And that's the data ops technology and process that's in there. And then, yeah, just so get started. So it's like you're building the proof of concept, but when you're doing that, you're not necessarily writing custom code or using, MQTT or UNS, for example, and building that out, because well, once I have that component, I can continue to add and invest in that, and it's only going to pay back and make things easier as I go forward. So yeah, don't boil the ocean, iterate quickly, focus on use cases, and really always keep in your mind scale in terms of that N+1 problem.
Okay. Interesting. So maybe let's kind of like focus on the topic of the unified namespace. So maybe first of all, to kind of set the context here for the audience, maybe just a brief description of what you envision or what you consider to be the unified namespace, and then talk about the role that DataOps plays in the unified namespace architecture.
Yeah, no, great question. There's a lot of confusion, I think, in the space. So like unified namespace and data ops are not the same thing, but they are complementary, right? And I think that's where the confusion is. So unified namespace today, practically speaking, is MQTT broker inside the factory, right? Like a HiveMQ. And it's the tooling, whether that's the PLC or HighByte or some application, to kind of model the data and push that into the MQTT namespace in somewhat of an ISA 95 hierarchy, right? And what's beautiful, what's awesome about that is once you start to do that, you're using open protocols, the data is contextualized, and it's kind of the central repository of the information in the factory. So the great news is if you're starting to move in that direction, when you come in with data ops saying that, oh, well, I want to take data for all the pumps in my UNS, for example, and I want to get that up into S3, AWS S3 into 1 hour Parquet files, so then I can go analyze that through machine learning. Well, if that's all in a UNS already, it's pretty easy to tap into that, get the data you need, and move forward. If you don't have the UNS, you're potentially going down doing Modbus or OBC UA or trying to like tap into these more native protocols, and it's going to be more difficult. So UNS complements data ops. And the other piece is like UNS isn't restricted into the factory either, right? Because you can, as you know, with HiveMQ, you can start to kind of build out that namespace. Then you can move parts of it to a global namespace by bridging brokers and doing some other cool stuff too. So I think it is a transport for data. The only other difference between DataOps and UNS is today, UNS is all report by exception, right? So it's really good for the real-time data that's coming through, which is most of the data coming off machines. But when you start to look at like transactional data in MES systems, when you start to look at historical data, like in Pi or historians, UNS isn't necessarily the best data path today because it's report by exception for some of that data. And data ops can help come in and massage that and mix the data together.
Interesting. Now, one of the center pieces of data ops, or maybe for HighByte Intelligence Hub in particular, is that ability to model, to create models of your assets, right? Can you speak to me about the significance of being able to do that? Like, what's the significance of doing that object modeling as far as digital transformation is concerned?
Yeah, it's all about context, right? So when you think about it historically, you're in a factory 15 years ago, someone set up a ControlLogix PLC, hooked that up to like a Kepware, with a control objects Ethernet, and then named some tag in there that happens to be the on-off state of the machine, and then pump that into like factory talk or some HMI, right? And that was when they went and developed that was their world. That's all they were thinking. Like, hey, I need to get the PL. I'm doing the ladder logic. I need the PLC tag, and then I need to get that into the HMI. They weren't thinking like stepping back and saying at global scale, we need to know what that is, right? And that's the piece that, even in the SCADA systems in the factory, not necessarily when they was implemented, thinking about that at global scale. So modeling is really, it's core to data ops because the data in the factories is, quite frankly, it's a mess, right? And it was never thought of at that holistic scale. So with a data model, you can come in and say, well, this is a press machine. It's located in Albuquerque on this line in this zone, and this is the on-off state. And if you can model it close to the source, so by the time it gets to the UNS and by the time it gets to the cloud, it's fully contextualized. You don't care what that PLC tag was. And that's good, right? You've abstracted that piece of information away.
So, like in most cases, some manufacturers may not really know what data they need, right, to build out this context or to build out like a proper data ops strategy. So can you speak to us about what are the typical sources of data which they kind of like need to look at and bring that information into the data ops? What are the typical data sources for integration into the data ops platform?
Yeah, great question. So you'll see there's kind of three buckets I put them in. Real-time machine data, right? That's usually going to come in through OPC. That's the way we typically tap into it. But that could be Modbus. It could be native protocols as well. But that's going to be just real-time status of the machines and kind of what's going on. Transactional data, that's going to be more your manufacturing execution system. So like what was scheduled that day to be worked on? What's the status of those work orders? And then the last piece is just historical data, which is the stuff that Pi or Canary or whatever historians in the factory is kind of recording. There's other data sources too that we run into. I mean, we run into like CSV files generated by test equipment, XML files. You're tapping into maintenance systems via REST, right? So what's really clear is if you're going to come in with a DataOps technology, you need a lot of different ways to connect to all the different equipment because there's just tons of interfaces. I mean, we still deal with SOAP interfaces a lot coming out of the ERP systems, and you'd be amazed at some of the transformations we have to do on the data just to get it in a format that's manageable. Yeah.
So maybe if we could talk about the actual practices within data ops, like things like data modeling, normalization, and contextualization. Could you speak about some practices that you see work a lot? I mean, you mentioned also kind of like some common mistakes. Could you maybe also highlight some common mistakes as far as those practices are concerned?
Yeah, for sure. So when you're talking about data modeling specifically, some common pitfalls I'll see. Folks will start and they'll try to model everything, right? So they'll try to model the entire factory as if it were like a digital twin, down to the like top level site area all the way down, right? And it's a difficult exercise to do, right? To go around and do that. So it takes time, and then by the end of it, if you did perfectly model, let's say you perfectly modeled it, and then you got it into the UNS or you got it into the cloud, what you'll find is the instant it lands there, someone's going to come in and try to use it and say, I need a change, right? Or I need something different, or I need like an increased sample frequency, or I need this in different units. So my advice there is to always, and I've already said it, like be use case driven. So don't your goal is not to perfectly model the factory and create a digital twin, right? I think digital twin is a cool academic concept, but in practice, it's not super practical today, at least where we're at. So really focus on, am I doing preventative maintenance? Am I doing energy monitoring, OEE, whatever your use case? It may be autonomous vehicle monitoring, but focus on that use case and the data set that you need for that, and start to think about data ops and UNS as like kind of this use case driven repository where I could come into a branch and be like, okay, this is these set of use cases that I'm driving, and this is the data that I need for them. So your models are less around, and you could create asset models too, but I think the most effective customers we see are use case driven models. The other thing is just to try to keep the model simple. We see customers come in with models with like 10 levels of hierarchy, 15 levels of hierarchy. You usually have to flatten that by the time you get it into cloud systems anyway. And there's a lot of cloud systems that will limit hierarchy even if it's supported. So like really try to bring it down to like a flat list of the minimal set of things that you need. Keep the context in the model is important depending on the system. So like site, area, line, that kind of information should probably be metadata in your model anyway. That way the data is self-contained, right? You don't need to reach out for additional metadata. Like it's all in the payload and you can use it as you need. The last thing I would say is a lot of folks get caught up on model governance, right? So they start and it's a super important concept. But when you're just starting with the idea of, well, how are we going to lock these data models down and how are we going to manage that when you haven't even implemented a data model that proves a use case that drives value for your business? It's premature, in my opinion, right? Because I think the governance piece is totally doable. Like we're adding features and HighByte and DataOps in general to help solve that. I think like HiveMQ just added some schema validation stuff I think that I saw, which is awesome. So I think the industry and the players in the industry will create the solutions around that. But I don't think you want to start with data governance because it can really slow you down. And those models early on are going to change a lot anyway. And the only time you really need governance is when you start to go to scale it across a bunch of facilities, right? So you've already proven the use case, you've proven the value, you're in the scale phase, and you just want to lock down the models so that you can manage changes to them at scale, which is important, but it shouldn't be like your first problem you try to solve.
Interesting. So maybe just to kind of linger on that topic a bit. So talking about governance and being use case driven, how much of what the consuming applications ingest should influence your data modeling strategy? Should you build based on what applications need to consume that data, or should you kind of like standardize or on a specific model and then look for applications that work with your model? What goes first? Which way do you kind of like?
It's a good question. I think you should go application down.
Okay.
Yeah, and really focus on like what is the data set that application need, or the use case that we're using in that application. Perfect example is we want to do conveyor monitoring and try to predict failure of conveyor belt motors, right? Well, what information do we need to do that? So you create a data model around that. You go then push that data down, collect it, connect to OPC or the data sources that you need. That would end up being like, let's say Azure Blob, or let's say you landed in S3 as files. You'd feed that, you'd have a Lambda or something that feeds that into TensorFlow to try to like train the model and start to predict failures. Then you'd have a feedback loop when you saw a failure to push it back down to the factory. But that data model is very specific to that application, right? And like I said before, if you've done the work in the factory to build out the UNS and make that data like easily available, you could tap into that and make it a lot easier. But ultimately, like the model piece that you really care about is that end application model. And maybe that conveyor belt model at scale saves you millions of dollars a year in downtime, right?
So when like approaching the issue of data modeling, there's kind of like options, right? A part of it you've already spoken about, like being able to kind of like customize it to suit a specific use case. And there's also like standard data models, right? Could you speak about what are the advantages of going down the path of trying to fit into a standard data model, and what are the disadvantages of that?
Yeah, so in my opinion, it is. So we start to think about model governance, right? I think it's beneficial to go pick a modeling standard that you could use as like your central repository of models. And maybe that's, DTDL for Microsoft, maybe that's OPCO information models, but it's a way to like in a standard define your model definition such that you can manage it, right? So I think when you get to that point, that's important. I think the idea of using standard models for plug and play, where like, this piece of equipment has a standard model definition that's, let's say, driven by MT Connect or OPCOA information models. I think in the space, the DataOps space we're in today, that plug and play factor isn't as relevant. It's just not, we're just not mature enough yet as an industry to really like embrace those modeling standards and really enable plug and play. I think OPCUA is an example of that, where like in certain niches, the information models are really useful, but then you step out of that and no one really supports via even the protocol or their implementation of the protocol, the information modeling, right? So I think when you start to think about governance, it's a really good idea. But the con is if you early on, you're probably going to iterate on your models really fast. And in my opinion, how you model your data is one of your competitive advantages over time, right? If you figure out that data model for the conveyor system that saves you millions of dollars a year, as a business, you don't want to necessarily standardize that because that's giving you a competitive advantage. So I think there's an element there too, where, hey, we want this to be flexible, in-house, and easily to change. That's more beneficial than trying to adhere to an industry standard at this stage.
Yeah, so I mean, as you have already alluded to, like, there's kind of like really a confusion between DataOps and MQTT. So all these technologies, maybe because they're kind of like really evolving at the same time, right? And could you kind of like explain what you see as being the role of MQTT within a DataOps ecosystem?
Yeah. So MQTT core to UNS, right, is a great way to kind of start to free up that data inside the factory, right? So like we're saying, you build a UNS on MQTT, report by exception, really good for real-time data coming through the system and make that visible. The only challenge there is that, and I think this is changing, like PLC communication. I mean, UNS somewhat competes with OPCUA in the factory. Like it's pretty clear that PLC to HMI, that's still OPCUA, right? That's not totally changing. Sparkplug is like eating into that a little bit, you could say. But I think like in it, not changing that, in addition to building a UNS on MQTT with JSON payloads, the beauty of that too is you can start to tap into stuff like AWS IoT Core or HiveMQ in the cloud, right? And once you kind of have that, you can start to bridge that data out pretty easily compared to other technologies to do it. I think did you mention Sparkplug? Or we might as well talk about Sparkplug.
Yeah, sure. Let's dive into Sparkplug.
Yeah, so Sparkplug's great too, right? When you see there is PLC is actually adopting Sparkplug, and it has the ability to templatize data as well as the binary format in Google Protobuf. So what's cool there is, compared to like an OPCUA, you can enable Sparkplug, push it into a broker, and things like SCADA or Ignition, for example, can kind of automatically fill out those tags, and they just kind of show up. Like it kind of feels like magic when you do it, which is pretty cool. The challenge with Sparkplug today, and I think this will change over time, is that as soon as you get beyond the SCADA layer, cloud platforms don't support native Sparkplug, so you need to do a translation, and it's not super difficult. But I don't see AWS or Azure in, I don't see them adopting Spark. I'd be surprised if they adopt Sparkplug at this stage. Maybe in the future they will. So you kind of always need that translation from Sparkplug out back to basically MQTT JSON. And I think that's being worked on in the standards body to help with that translation. I think that's a known obstacle with Sparkplug, but really interesting. And again, UNS, if you start to build that in the factory, it's only going to help your DataOps strategy because you can easily tap into that data that's just readily available in the broker.
Yeah, I mean, you've already spoken about the role of OPCUA. You've touched on that a bit in a DataOps strategy. I don't know if there's a clear line of demarcation, but are you able to speak about where do you think the role of OPCUA falls within that kind of like DataOps or data integration between IT and OT? And could you speak about the role that OPCUA plays within a DataOps strategy?
Yeah. OPCUA is critical to DataOps strategy because it's in the factory today, right? And it's not going away, and it does serve like a really important place, right? Like I said, in that communication between PLC and HMI, you usually have an OPC server, and that's like a tried and true. It works. Probably not going to change. Maybe even in 10 years, right? That it's just going to be there, just the kind of the way manufacturing works. I think OPCUA has some really great qualities. Security is one of them. It also has the ability to do pulled reads on data, report by exception through subscriptions. It has the ability to do writes, right? Transactional writes, which aren't UNS can do it, but it's not trivial and it's not as transactional, let's say. So I think when you're doing, writes down to a PLC, doing that through OPC-UA makes a lot of sense in terms of just robustness. So I think, if you have a DataOps platform, even if you do have a UNS that you're building out, you want to be able to connect into that and use that, but you also are going to need to tie directly into UA sources, guaranteed. So that's a critical component. I think it was one of the first connectors we built. I wasn't around. It was Tony Payne, but I think that was one of the first ones. Yeah.
Yeah. Interesting. Yeah. So now, one of the other confusions that I actually personally experience a lot when I talk about unified namespace is this fact of so that unified namespace is like a real-time data, right? So that's like your snapshot, and a lot of questions that come up is how do I get access to history, or do I get historical data with unified namespace, and all that kind of questions. What to you is kind of like an ideal interaction between unified namespace and historical data? How do you see them playing together, or ideally, how is that interaction for you?
Yeah, great question. This gets brought up very early on in the journey of UNS for most companies. That this and the transactional stuff. So I think there's two sides of this that I think of. The first one is, I think, more related to your question of, well, maybe not, but data is flowing through the UNS, real-time data, right? Report by exception data. So customers will say, hey, well, I actually want a historical log of that information. So I actually want my historian to feed off of the UNS, and then I want to come in and say, hey, what was the 10-minute average speed on this conveyor, for example, right? And that's really an historian feature. So UNS being mostly around MQTT is not going to provide that out of the box, right? So today, what we see is people will connect into the UNS and then they'll listen to certain feeds and then store that into Influx or store that into OSIPy or whatever historian they have, and then use some other interface to come in, whether that's REST or whatever native interface that has to be to access that historical data that's coming through the UNS. It's a little tricky because UNS is if you think about it as JSON payloads or Sparkplug, it is complex data, right? So you need a historian mechanism that can kind of store that and or flatten it enough with context to be able to pull that back out. Interestingly enough, this is an area, HighByte, we just added a REST API onto our product to come in and do transactional stuff. So to get the real-time state, after you've modeled something, you just come in and make a REST request and say, hey, what's the current state of this? Our ultimate goal is to kind of start to fill some of that need in UNS, where you could tap into data streams, store that in your native historian, and then provide that REST interface to come in and say, hey, on this asset, what was the 10-minute average? Or give me the data for the last. It's almost like a translation layer between a native historian and taking that UNS data and finding out how to package it in that historian and then pull it back out so you can answer those kind of questions. So that's one aspect that I think the industry will start to fill in, that kind of historical data of UNS. The other component of that question is, well, what if I already have an historian that has data in it? How do I represent that in the UNS? I think the short answer is you don't. The stuff that makes sense to represent in the UNS is well, I want a 10-minute running window of values, or I want an average, or I want a min-max over the last day. That kind of aggregate information makes sense. But when you look at customers that say, hey, I'm trying to get 2 years worth of Pi data into my cloud system, that's where you wouldn't go through a UNS to do that. And part of that is just MQTT has a limit on payload size of 260 megs, which is pretty big. But when you start talking about gigs of historical data, you really don't want to run it through that pipeline. You would treat, it's almost ETL you would treat that differently outside of UNS.
Okay.
And that's where DataOps would help you.
Maybe to kind of quickly focus on the REST API aspect of HighByte that you recently added to it. So do you kind of envision a situation whereby maybe in the context of a unified namespace, a component is feeding off real-time data from the unified namespace, and at the same time, it's also maintaining a connection with over a REST interface to kind of get that transactional information? Is that kind of that picture that you are building here?
Yeah, exactly. So we put out a few of it, but like an idea that you could subscribe into the UNS and you see like a pump come through with its kind of current status. And then you want to come through and like, well, and maybe the pump doesn't make sense, but maybe you like that has a pump ID on it and you want like the most recent work order information. Well, it'd be nice to have like similar to your UNS namespace, your MQTT namespace that's like site, area, line, pump, X, to be able to query something similar to that over REST and then pass it like a pump ID to say, well, give me the work order information for that pump or the most recent work order that was done on it and be able to return that back. And really, it's just an abstraction layer between, the client and then all the underlying systems. But really, if you can start to harmonize the UNS namespace with some kind of transactional namespace, even the same thing. If I can look at that MQTT topic that goes out to the pump, and I can make a similar request over REST that says, "Well, give me the data from now to 30 days ago," and out comes this payload of like the historical data, and it's harmonized over that address space. That becomes pretty cool, and it just makes sense. That's kind of where we're trying to head with HighByte in terms of integrating with UNS.
Makes sense. Okay, so to kind of like wind down conversation here, do you have like some advice, or maybe you can speak about some common mistakes also and pitfalls that organizations need to look out for when implementing a DataOps strategy?
Yeah, yep, sure. As I mentioned a few of them, but we can bring them back up. One thing I would say is just don't try to build it yourself. I think, a lot of our customers, the good news is when someone comes to us and they say, hey, we tried to build this ourselves, they felt the pain of the scale problem pretty quickly, right? So you don't really need to sell them on the scale issue or why they need a solution. They're already kind of there. But if you can avoid that and the expense to try to go and build it and write custom applications and try to manage your own source code, I would do that. The other thing is, like I said, I really think when the problem you're trying to solve is not getting all the data to the cloud. It's not digital twin perfect modeling. It's the N+1 problem of, hey, we got a data set up there, we learned from it, and now we need to change it at scale. How do we do that at near zero cost? And that's the tooling, that's the process, that's the team around your whole DataOps strategy. Let's see. Avoid. So don't try to get all your data to the cloud. You can. There's an interesting, since I'll just bring this up because it's an interesting conversation, but there's this interesting idea now that with stuff like ChatGPT in these linguistic language models that I could just throw all my data in the cloud and then use something like ChatGPT to be able to build the data models that I need there, right? Which is cool. I actually want to go off and start to play with some of that. I have it on whenever I get time to see how practical that is. My intuition says that, well, like we were talking about before, if we're going back to that PLC tag that was named by the controls engineer out in Albuquerque on that very specific use case, there probably isn't enough context or intelligence to be able to distinguish that, oh, that's the on-off state, or that's a vibration on this thing by just like a tag name and some of the data stream that comes through it. And I think I actually saw something on LinkedIn where someone tried to do this with Modbus, and it was difficult. Like it kind of showed, but I think it's still it's an interesting question, right? Can I push all the data and then try to put the context around it using something like ChatGPT? But my intuition says probably not going to work at scale. But if you're using UNS and you're modeling your data to some extent, so by the time it gets into the cloud, there's reasonable context around it, aside from just a tag name, then probably that enables you to use those tools more effectively, right? To start to build the applications that can use the data without actually writing code yourself. So I think that's an interesting area I'd like to explore too. We'll see in the future, but for now, I would say don't start your strategy with, let me get all my data to the cloud, because when you're talking like I have 1 million tags and I'm trying to figure out how to transport and land those in the cloud reliably, it's expensive and it's a very difficult engineering problem to solve. Focus on end use cases. I've already kind of said that. I really think the future of UNS and just in the factory, this whole DataOps thing is use case driven, and it's really what you'll see is like a repository of use cases. And I really think, like as an industry, what we're moving towards, we're really taking cloud technology and we're moving that down closer to the edge. MQTT is an example of that. Kubernetes, Docker are examples of that. And it's almost like you can start to think about as what we're building in the factory is really, it's starting as DataOps, and DataOps is a really important part of that, but it's really almost like an edge data lake, right? Where we're doing some historization of, we're providing access to real-time data, we're historizing some of that over UNS. And right now, most of the consumers of that are in the cloud, but you can start to see as you build that on the edge, and you can orchestrate it via Docker, Kubernetes, or however, factory systems will start to tie into it too to get data, right? It would kind of become the central repository. I think that's where we're headed, and I think that's going to be very use case driven in terms of like the data modeling, et cetera. I think DataOps too, it's an interesting realm where it's a mix of IT and OT people, right? It's people, it's process, and it's technology. So if you're looking to hire for that, kind of build those teams out, you really want someone has really good IT skills, but understands the complexity of the OT world, right? And like when I talk to IT people that just don't get it, I often say, go walk in a server room, right? Just take a walk in a data center and come out, and then go walk in a factory and tell me what was different, right? Pretty significantly different. So you want someone that understands that complexity. And the other, I already mentioned it, but I would really start to look at edge computing platforms too. I think that's really important as this stuff starts to scale, to be using Docker and Kubernetes at the edge. I think our most advanced customers are starting to do that. And it really helps with the deployment and management at scale of these types of solutions. So I think if you're not already starting to look at that, I definitely would.
Awesome. I mean, you brought up an interesting point about like the people, right? So would it be right to say that part of what DataOps also solves is this need to capture what is called like tribal knowledge? So would you say DataOps is also a way of capturing all this and documenting this tribal knowledge?
Yeah, or at least abstracting it away to a level that you don't, at some level you don't need it anymore to understand. But it's definitely an IT/OT project, right? And I think the key, even for us with our customers, is it's typically more IT driven, but there's people that understand the OT problem. But what you don't want to do is your DataOps strategy can't put a ton of work and effort on the OT folks because they're already swamped and they're already limited in their manpower, right? So you can't like give them a big science project, but you need to give them the interfaces and the tools that are familiar to them to be able to put in their tribal knowledge, because they're the ones that know PLC tag X, Y, and Z goes to like on-off state vibration. So if you can just give them the simplest task to be like, hey, could you just fill this in your free time? And once they do that, okay, we've got the data with context and we're good. But if you give them like a giant science project up front, they just don't have the time to do it, right? They're trying to keep the lights on, focused on production. So it's a balance for sure.
Absolutely. Okay, with that, we come to the end of this session. So Aron, thank you so much again for taking the time to come out onto the show and share insights with the audience. Really appreciate it.
Always a pleasure to talk to you, Kudzai. Yeah, anytime.
Thank you.